Hey guys, so today I'm going to be showing you how to make a basic rigid body FPS controller in Unity. Now some of you guys want to know how to change the sensitivity of an FPS controller through a slider. So I thought about it and I decided to make an FPS controller tutorial so that you can understand a bit better. So here's what we're going to do. Alright, so we're going to make basic movements and rotation. We are also going to implement the ability to walk upstairs and slopes. Of course, jumping is involved and changing the sensitivity, as you can see right here. Basic stuff, pretty easy. You should be able to follow along. Alright, so I've got here an empty scene. First things first, I'm going to make a ground cube. Next step, we're going to add the player. Let's go through the object, add a capsule. Let's move that up a bit, and that should be okay. Okay, let's start by putting the camera under the capsule, and in the capsule, just remove the mesh renderer. You can leave it off, but just only shadows only. That means it will only cast shadow. I think that I prefer that a bit better. Alright, so add a components. Let's add a player controller component, add script and create an ad. So first things first, we're going to add a public float and let's call that speed, and I will make that default to 100. Before I forget, let's go up here and require components type of rigid body, because we're going to use the rigid body to calculate the motion player. So let's go into the update method and create two vector 2s. One will be the x move, and one will be the d move. Now, you probably are wondering why I'm creating vector 2s and not just floats. Well, we are creating vectors to calculate the relative x and z vector on the player. That means that we want to move forward relative to the player's rotation, right? So set that equal to a new vector 2, and inside of that we need an inputs.getAxis raw. We're going to use raw because we don't want any smoothing applied. Alright, so inside of here we want to get the horizontal axis. Make sure to write it correctly, because otherwise Unity will give out an error. And then we're going to multiply that by transform.rise.x. And the same thing for the y component of the y vector. I want to make an inputs.getAxis raw, and this time again the horizontal, and multiplied by transform.forward.z in this case. Alright, so in the other vector, just copy paste the above and change from horizontal to vertical, and from transform.rise to transform.forward. In this case, transform.forward.x and transform.forward.y. Make sure this is rise. I did that by mistake. Alright, so now it's time to apply the velocity to our rigid body. First things first, we want vector 2. Let's call it velocity, and set that equal to the sum of the vector 2's above. So x move plus y move, then normalize the sum. That means that we want to move faster when we're going sideways. And let's multiply that by speed, and you guess it, times delta time. So the speed of our player is not going to be affected by the frame rate of the game. Okay, so let's go up here and create a rigid body called RB, and on the start method we set RB equals to get components type of rigid body. Alright, so at the end of the update method we're going to set the RB.velocity equal to a new vector 3, and then on the x component will be the velocity.x. On the y though, we're going to be rb.velocity.y, so we don't really want to affect the velocity on the y-axis, so up and down. And then on the z, we're going to make velocity.y because it's a vector 2 and not a vector 3. Right, so if we save and go back into Unity, we should be able to see the speed right here. And let's go ahead and add a rigid body. So before you hit play, go to the constraints and hit freeze rotation X and Y. And that will actually help so that the player won't rotate while we are moving forward. Also, I forgot about it. Go to the camera and just reset the transform and move that a bit up so the camera sits around about at the heads of the player if you want to think about that. So I'm also going to add some cubes as obstacles so that we can identify the movement of our player. As you can see, we are moving perfectly when I'm pressing the ASW keys or the arrow keys. Right, so the next step is the rotation. So for the rotation, we need some variables. First things first, we need a public float sensitivity, and then we need a camera, and on the start method, set the cam equal to camera.main. Firstly, we're going to rotate around the y-axis. To do that, we want a float y rotation, set that equal to input.getAxis raw, and this time we want the mouse x-axis, and multiply that by sensitivity. Now this input.getAxis raw mouse x, so the mouse x-axis, return a value depending on our speed of the mouse. So we can use that to rotate our player on the y-axis. Right, so to apply the rotation, it's actually pretty easy. You go to rb.rotation and multiply that by quaternion.euler, and we want 0 y rods and 0 again, and multiply the y rods times time.delta time. And that's pretty much it. So you probably are wondering why we are multiplying two quaternions. Quaternions are a bit weird, but to rotate a quaternion, you, instead of adding them, you multiply them. So this is the easiest explanation that I have. I don't really understand them very well, but this is how they work. Right, so here in the player, you can see, let's drag that down the script so you can see that a bit better. You can see this sensitivity. Let's scroll that up to 2 and let's hit play. And as you can see, I'm moving the mouse and rotating. Let's crank that up, this sensitivity a bit more to 20. Yeah, that's a bit more like it, and you can see I'm moving forward relative to the player's rotation. The movement is a bit junky because I'm currently recording. Now we're not done with the rotation of course. We want the rotation on the other axis up and down. So it's a bit more complicated, this one, and we don't really want to rotate the player. I want to rotate the camera instead. That's why I added the camera here, because we don't want to rotate the whole player. Instead, we want to just look up and down with the camera. So to do that, let's make a float x rods in this case, and you guessed it, input.getAxis raw, this time mouse y, and multiply that by sensitivity. Right, so to apply the rotation on the camera, we actually need some more variables. We're going to make a variable called xcam rotation, and that will equal to cam.transform.euler_angles.x. Then we're going to subtract x rotation from the xcam rotation, so x rods. So xcam rods minus equals to x rods. Of course, we're not done. We want another float again, and let's call that cam Euler angles x equal to cam.transform.local Euler angles and .x. This time it's local Euler angles and not just Euler angles. And now we want to subtract the cam Euler angles x from the negative x rotation times the sensitivity. And now we can apply the rotation by writing cam.transform.local Euler angles equals to new vector 3 cam Euler angles x 0 and 0. So I actually accidentally puts twice times sensitivity. So remove that. As you can see, it's inverted. So if that's the same with you, go over here and instead of setting that minus equals to x rod, just remove that entirely. You can see this is exactly how it should work. Now I can see another problem right here is that the up and down rotation is much faster than the right and left. If that's the same with you, you can go back to your code and instead of having two sensitivities, you can make another public float y rotation speed, let's call that, set that equal to I don't know, 10. We can change that from inside of Unity, and instead of only multiplying by sensitivity, you will multiply by y rod speed as well. So now this y rod speed will indicate how fast the y rotation or the right and left rotation will be. As you can see, it works fine. I think the sensitivity is 2.5, so I'm going to change that to 8. We should see that it works fine. Again, the rotation is a bit chunky because I'm recording, so in your case, it should be much more smooth. Alright, so I think this is the time that some of you are waiting. We are going to make an options menu with a slider that we can change the sensitivity from. To do that, we're going to add a UI slider, and if we go to 2D and focus on that, going to move that a bit in the center, and I'm also going to add a UI text, make it a bit bigger, and let's write sensitivity. Alright, so I think that should be okay. I'm also going to go and add a UI panel, and let's drag all of them under the panel, and let's add that to be the pause menu. Alright, so now we are going to add another script in the canvas, and it's called pause menu script. If you do have a pause menu, you don't need to bother making anything like that. You can just skip to the slider tutorial. It should work pretty much the same. So over here we want to have a public game objects pause panel. We don't need the start method. In this case, we want to check if the player press the escape key, get key down, and we want the key code.escape. Don't forget, we also want a boolean as pause. So we need to check. We need to firstly set that is pause equal to not as pause. Will actually invert the pause state, and then we need to check if it is actually paused, and if so, we want to pause panel.setActive to true. Okay, and else just copy that and set that active to false. Right, I'm going to also make some more adjustments. Let's put that public. We will use it in a sec. I'll show you why. And let's make it tag height and inspector, so we won't be able to change that from Unity. So inside of Unity, we're going to go to the panel canvas and drag in the panel menu, and also don't forget to deactivate it first. So now we should be able to see that if we hit escape, the panel menu appears, and if we hit escape again, it disappears. Right, so now we want to freeze the player so the player can't move while the game is paused. To do that, inside of the pause menu script, I want to set time.time tail equal to 0 if it's paused. Otherwise, we want to set that to 1. As you can see, we are moving correctly, but if I press escape, the pause menu appears and I can't really move, but I can't change the rotation of the camera. So we need to fix this. To change this, we want to go back into the player controller. We want to add a pause menu. Let's call that pause menu underscore pause menu, so it doesn't. And when the start method, we want to set the pause menu equal to find object of type pause menu. I actually set it this boolean to public, and this is because we want to access that from another class. So what we're going to do is access that boolean, and if it's not paused, we want to apply the rotation of the camera. To do that, it's down there. Check if the pause menu, if it's not paused, we want to apply the rotation on the camera. We are able to see that we can rotate and move correctly, but if I pause, I'm not able to do anything, and I'm able to adjust the slider. So now it's time to apply the sensitivity. To do that, we want to create a method let's make a public void change sensitivity, and then we want to pass a float and set the sensitivity underscore sensitivity. The reason we're going to make a public class is that the slider is able to access it and call it. We need a float so that the slider can pass in the value directly and to the function. If we go down to the slider, we're going to press the plus button right here. I'm going to move the player inside the object slot right there. Now we're going to choose the player controller script, and you can see that our newly created method is under the dynamic floats. Now this is because as an argument it takes a float so that the slider can recognize it and pass in the value of the slider directly into the function. Now we also want to change the min and max value of the slider so that it matches the sensitivity that we want, so the max range, min and max range of the sensitivity that we want. I'll go ahead and go like from 2 to 10 for example, and I set a default value of 8. We are able to see that we can rotate and move, but if we pause and change the sensitivity, let's put that on the extreme down, we're not able to rotate at all because it's 0. We need to change that. Let's change that to 2. So now it's 2, you can see, so we can move very slowly. But if I change that up to 10 for example, I can move much more. I think I'm going to change that from 2 to 15 for example. I think that's a good choice. You can play around with the values for that and which work for you. Right, so next we do have a few small problems. First problem is that if we look down, you can see kind of glitches. Also, you can see the mouse and the cursor, and it's not locked in the center. So let's fix those. So let's go with the cursor first because it's actually pretty easy. All that we want to do is go to the start method and set cursor.lockState equals to CursorLockMode.Locked. That will lock that in the state in the position where it is, and then cursor.visible equals to false. So we won't be able to see the cursor. We also want to change some settings right here, so just go ahead and copy those. Go into the pause menu and if it's paused, we want the lock mode to be confined so that you can move the cursor, and in the visible it should be visible, and if it's not paused, we want to change that back to be locked and false. So if we save and go back into Unity, you're able to see, you are not able to see the cursor, and if I hit escape, you are able to see the cursor and move it. If I hit escape again, you are not able to see the cursor. So now we're going to fix that glitching thing that happens. We are going to go back to the player controller, and so the way to fix it is to use a Unity built-in function called mathf.clamp that will clamp a value from min and max range. To do that, we can use a clamp Euler angles x equals to mathf.clamp. Clamp the value clamp Euler angles x from 270 degrees to 450. So this will work for values smaller than 360 degrees, but it won't work for values larger than 360 degrees because it will never be higher than 360 degrees. To fix it, we're going to check if Euler angles x is smaller from 180 degrees, and if it is, we want to add to that 360 so it goes up over 360 degrees and we can clamp the value correctly. Now we don't need to subtract anything because Unity will automatically apply the rotation correctly. So if we save and go back into Unity, as you can see, you are able to see that it just stops right there. It doesn't glitch or anything. Yeah. So now we need to jump. To do that, I'm going to go back in the player and let's focus on that. Let's go out of 2D mode. Let's focus on the player, and we want to create an empty under that, and let's call that jump. And we want to move that half of the height of the player. So the height of the player is 2. So we want to move that down by -1 point. A small amount. I would add 1, for example. to minus 1.1. As you can see, it's barely under the player. Right, so let's make the jumping. First of all, we need to have a public game object, and let's call that jump check object. And down there, we want to make a boolean is grounded, call that, and that will equal to physics dot overlap box. So that will create a box and will return true if something is in that box, is in that region, and false if it's not. And inside of it, we want the center box. And let's call that jump check dot transform dot position. We also want the size of that, so let's go and set up public vector 3 jump check size, and let's put that over here. So jump check size, and then want to check if the length of that array is bigger than 0. That means if there is a collider or an object that has collision on it inside of that region, then return true. Then we're going to check if we are grounded, and if we do, want to just jump. I haven't created the method yet, so let's do that right now. Let's call it float jump. We're going to need a float. Let's make the public float jump pause. Let's set that equal to, I know, 700. You can change that later. And then we're going to go to rb.add pause and add a new vector 3 as a pause, 0 on the x, and jump pause on the y. Oh, I also forgot to check if we are pressing space. So if we do, check inputs dot get key down as get the key codes dot space. I made a mistake. Let's change that to 1. Drag that into the slot right here. I've done that already, and change the check size. I will go with 0.3 by 0.5 on the y, or 0.4. I make sure it's under 0.5 and 0.3 on the z. And if I hit space, I'm able to jump. It's actually pretty high, so I have to reduce the jump force. Right, so this is pretty much the movement, but a small bug that we have. If we move around, yeah, you can see due to the friction that we have with the boxes, we are moving around. To solve that, we're going to freeze the rotation on the y. Next step is the stairs and slopes. So the way that we are going to do that is we want to check for a lot of arrays or overlap boxes. In this case, because we are in 3D, and then we are going to move the player up accordingly to how many of those are hitting something. That means that in this case, they hit 2 of them are hitting this first step. We're going to just move them up to about this height, right? This is the height that we're going to move the player up, so we are sure that it will be above this step. Now, this works actually pretty good for slopes as well, because slopes, if you think about it, are just stairs with infinite steps. In this case, we want to move the player only about this height. So this is pretty much all there is to it. So let's go back into Unity and program that. Right, so inside of the script, we want some variables. Let's create a public float, and let's make that max step height. And let's set the default to 0.5. That will be the max height that we can climb on. We want also a float to indicate the detail, and that is how many checks we're going to make in the range of 0 and max step height. So let's default that to 10, for example. I'm also going to add a public layer mask, step mask. We are sure that we want to climb up a stair or a slope and not something else. Right, so go down here. I'm going to add the stair functionality right down there. I'm also going to move that down. So we want to apply the position or the velocity at the ends. I'll make a for loop. I'll actually make that inverted. So instead of going up, I'm going to go down, and I'm going to start from stair detail, and that would be equal or bigger or equal to 1. And let's make that minus. So that will go from stair detail down to 1. So actually that was my fault. Let's change that to ends. The stair detail should be an integer, not a float. And then we're going to create a collider array. Let's call that C, and let's set that equal to physics.overlap box. So I want to set the center on the transform.position minus a new vector 3 with components 0, I times max step height divided by error detail. And then we also want the half extents. Of course, you can change it for your game, but I'm going to default them to 1.05f. I found that was the best. And then max step height divided by their detail divided by 2. Because it's half extents. We want to apply the rotation, the pattern.identity, and then the layer mask. So it's red, just the mask. Oh, I also forgot. Don't forget that because I'm at 30 minutes right now trying to fix that. As 0.05f on the C components, otherwise it won't work. So then we want to check if we are moving. Velocity is not equal to 0 because it's not equal to vector 3.0. And that's a vector 2, that's not a vector 3. And if it is, we want to check if the C dot length, if it's bigger than 0, then that means that there is something inside of this bounding box. Then we want to move the player up. I'm going to use transform.position in this case, because we want that to be an instant change. The transform.position plus equals to new vector 3, and then we want 0 on the x, and I times max step height divided by stir detail. And that's all that there is to it. We are able to see that we have a mask and some variables right here that you can change. I won't change that to everything just right now. But to add stirs in Unity, you need a package called ProBuilder. So if you go to the package manager, you go to Window, Package Manager will just open the package manager for you. It's down there and search ProBuilder. It's right there. Just install it, hit install, and wait for it to install. It takes a bit of time, so I will be back when it's ready. So as you can see, I'm ready. It's installed. To open up the window, I'm going to go to Tools, ProBuilder window. I'm going to drag that into the side right here. And to add a new shape, just pressing new shape. I'm going to choose from the drop down a stir. I'm going to just build the stir right there. It built, and you edit an object. Let's move that a bit. Actually reset the transform and just move that. Move that somewhere like there. I'm going to go to the stairs and add a layer. Add stairs and add the stairs layer. And go into the player and change from everything to the stairs. You will also able to see that if I move, I actually going to be teleported up. Also, I've added another one. You can, if I move up and hold forward, I'm able to stuck in mid-air. To fix that's not that hard at all. So let's go up here and we're going to add 2 buttons. If is first check, and that will equal to false. So if that will get equal to true if we are on the first loop of the for loop. And another button of can move. Inside of the first if statement, I'm going to add another if statement over it, and if I'm going to add 2 conditions. If c.length is bigger than 0, and if I is equal to stir detail, or if it is the first loop of the for loop. And then we want to is first check equals to true, and then we want to check if it's grounded. If it's not grounded, sorry. So if we are in mid-air, then we want to say can move is equal to false. And down there where we apply the movement, we need to check if can move is true. If it is, we just want to apply the movement. Okay. Also, I'm going to set can move to true at first, and then on the second, on the last if statement, I'm going to add another condition that checks if it is in the first check. As you can see, I've added a stir, as I said before, but you can normally go up and down stairs. You can't go sideways like that. And if you move, I'm pressing forward right now, it doesn't do anything when it's getting stuck. I'm not able to go up this stair because it's too high. I'm able to go this stair though. So let's go in the scene view and let's add another cube. Let's go 3D object cube, reset the transform of that, move that a bit like that, scale that up like this, not on the Y, scale that down on the Y, where's my cursor, and just rotate that on the Z, I believe, yep, that's the one, and just move that like that. Let's go on the scope, you are able to see I'm actually going on the slope, and I am flying off apparently, there we go. So this is pretty much it, guys. Thank you so much for watching the video. If you like it, be sure to hit that like button, and if you want to see more videos like this in the future, be sure to subscribe. Also, if you do have any questions, feel free to comment down below. So see you in the next video. Bye.